Okay, in this session we're going to talk about water and its properties. And I must make mention that we've moved from atoms being the building blocks of matter. Now we're doing water and its properties. Then we're going to proceed to biomolecules. We'll be talking about proteins, carbohydrates, fats, and lipids. So in this session, like I said, we're going to talk about water and its properties. So we're going to start with some of the characteristics of water and the structure and the shape of water. Yes, and the properties and some exam questions at the end of this session. Now let's begin. What are some of the characteristics of water? We won't exhaust all of them. So we're saying water has three states. Now what are those states? We're talking about a solid. You're talking about the solid. You're talking about the liquid part of water. You're talking about also the gaseous state of water. So these are the three forms of water. Now water is found on earth in all its three forms. So you can either find it in gaseous form, in liquid form, in solid form, depending on how you want to store the water. Is it you want to store it in a bucket, you find it in liquid form. Do you want to store it maybe in a fridge, or you find it probably in solid form like that. So water has all these states. Now scientists used certain ways to describe water changing from one state to another, because for us to have water to be found in all the states, it's because of these three states. So when water changes from a solid to, let me say, to a gas or to a liquid, that one is called melting. I'm sure you know about that. Then when you're moving maybe from a liquid to a gas, that is called evaporation. Then let me say from a liquid to a solid, that is called freezing. From a gas to a liquid, that is called condensation. From a gas to a solid, that is called frost. Solid to a gas, that is called about sublimation. So because of these changes that water can undergo, we find that it's found in all its three forms on earth. Now let's proceed. Let's look at the structure and the shape of the water molecule. Now water is made up of let me say hydrogen atoms and an oxygen atom. So with me here I've got diagrammatic representation of how the hydrogen atoms look and how the oxygen atom look like. So like we did our atoms in our first lecture, the first part is the nucleus. The center of the atom is the nucleus, and in the nucleus, that's where I find the neutrons and the protons. Then outside the nucleus, that's where I find your shells, where you have electrons in the orbitals. And we said the orbitals, these are that's just the location where there's a high probability of finding an electron. And we gave an example where we're saying the electrons are just like your bedroom. Your shells are just like the house. Then in that house they're what we call sub-levels or sub-shells. It means in that house you find rooms. Now in those rooms again you find bedrooms. Now those bedrooms are just like orbitals. That's where you're likely to find you as a student. You're maybe usually in your bedroom or in your room, and like in other, maybe in like the whole hostel or like that. Yes, so that's where we're likely to find you. So for hydrogen has one proton and one electron. Like we earlier said, in a neutral atom, the number of protons, then the number of protons is equals to the number of electrons. So in a neutral atom, so if you've got one proton, you also have one electron, and electrons are the ones that are involved in chemical reactions. So now we've got one electron for hydrogen, and this is oxygen. Oxygen is number 8 on the periodic table. It has 8 protons and 8 neutrons, and those ones have been nicely shown on the diagram. So now how do they get to react? Now they tend to form what we call covalent bonding or covalent bonds. Now covalent bond, like we said in our earlier lecture on atomic structure, we said it involves the sharing of electrons. Now I'll still ask the same question: which one is easier for oxygen for it to attain stability in its last shell, or the valence shells? The last shell is, we call it the valence shells. Oxygen in this case has got, let me say it has apologies, here there's supposed to be another one. Yes, so 1 2 3 4 5 6. Yes, oxygen, it has, proton number of 8. So the first two, they'll be in the first shell, then the last 6 will be in the last shell, and the electrons in the last shell are called valence electrons. In this case, oxygen has got 6 valence electrons. Now, which one is easier for oxygen? To lose all the 6 so that it gains stability, or to just gain 2 so that it gains stability? So for oxygen, it can easily gain 2, but now it gains those 2 by sharing with the hydrogen atom, because oxygen is more electronegative, so it tends to put electrons towards itself. So what will happen, this will be the arrangement. Hydrogen will share one of its electrons, then same with oxygen. So on the other hand, same with the other side. So now, how many electrons are we going to have? So here we've got 1 2 3 4 5 6. Now because this one is shared and this one is shared, you have 7 and 8. Now oxygen has attained full stability. But now you should notice, now this is what you should notice. Now that it has shared other electrons, you find that other electrons will remain like unshared. Like you have 4 unshared pair of electrons. So you've got an electron here and an electron here, and these other 2. So 4 of them will be unshared, and like the other ones will be shared. So now those 4 electrons, electrons are negatively charged, and they tend to, negative and negative tend to repel each other. So we find that the shape of the water molecule will be different. So now let's talk about now the water molecule itself. So with me here, I've got a hydrogen and an oxygen atom. Now if you look at the shape, it tends to be like it's a bent shape. Now why is it bent? It's because of those 4 lone pairs of electrons. Those electrons that are not shared, they tend to not like to cause this structure that we are seeing here. So the question is, why is the water molecule bent, and what do we call a molecule with a positive and a negative end? Now this is hydrogen, it's partial positive and partial positive. This is oxygen, partial negative and partial negative. How does this come about? Oxygen is more electronegative than hydrogen, so it tends to pull electrons towards itself, making the hydrogen less like electron deficient. So in the end, it will have a positive charge. Oxygen, which wants those electrons, it will have an excess. That's what I can say. But now this is not like a full charge, it's a partial charge. So now why is this structure bent, and why is there a 10 like 5 to 109 degrees angle here? There are 2 reasons. Number one is that the arrangement of the orbitals around the nucleus of the oxygen atom causes this. Then the other thing is that because of the unshared pairs of electrons in the oxygen atom, these ones repel the shared pair of electrons, so that the hydrogen nuclei are pushed towards one another. As a consequence, the molecule is bent. Now this is the one that leads to the angle to be made between the oxygen and the 2 hydrogen atoms, and the range, like we've said, is between 105 to 109. As water molecule is bent and the charge distribution across the molecules is unequal, there is a positive and a partial negative end. And what do we call a molecule with a positive and a partial negative end? We call it a polar molecule. It's called a polar molecule. Yes, it's called a polar molecule. So polar, in this case, it has a positive, it has a negative, it has a positive end and a negative end. So it's called a polar molecule. Now let's proceed. Now What are some of the properties of water? Properties are just the features, the characteristic of something. So what makes water water? So these are some of the properties that water has. We're saying water forms hydrogen bonds. We're going to talk about what hydrogen bonds are. Water, we're saying water is a universal solvent. We're going to talk about what a solvent is and what a universal solvent is. Then we're saying water is a liquid at room temperature. Then we're saying water has high melting and high boiling point. It has a high specific heat capacity, and the density and the freezing point is also high, and it has high surface tension. Now let's talk about these one by one. We're saying water molecule, it forms hydrogen bonds. Now this is our diagram here. We've got one water molecule here. This is our first water molecule. Let me say this one is our first water molecule. Then our second water molecule is this one from here. Now these are two water molecules, and we are able to see a bond here being formed between this one water molecule, let me say this one, and this other one. So this bond that forms between two water molecules is called a hydrogen bond. Now notice how the hydrogen bond forms. It's between the oxygen molecule, which is partially negative, and the hydrogen molecule of another water molecule, or the hydrogen atom of another water molecule, which is partial positively charged. Now we say positive and negative, they tend to attract each other. That's why that bond can easily form. Now you should note that these hydrogen bonds, they are weak interactions, so they tend to break and form in the water molecule. That's why water has that liquid part. So the positively charged of one water molecule is attached to the negative charged end of another water molecule, and the force of attraction in this case we've said is the hydrogen bond. And now this hydrogen bond is at its strongest when you have an oxygen, when you have a hydrogen and another oxygen in the same line. Now you can have another arrangement where you have you've got, let me say, you've got H here, you've got you've got O here, okay, let me say you've got another H here. Okay, this is one water molecule, then this is making a bond, let me say, with another water molecule. Now this can go like this. Now because these ones are not in the same line, you've got an oxygen, a hydrogen, and another oxygen. Because this is not in the same line, the bond is not that strong. So we're saying the bond that is very strong is when they are aligned in a straight line. So I thought of mentioning that. Now which ones are stronger here between the hydrogen bonds and the covalent bond? The covalent bond, we said that it forms by the sharing of electrons. So I find that this is oxygen and a hydrogen within one water molecule. So in this water molecule, oxygen and hydrogen will share electrons for oxygen to be more stable or to attain stability. And a bond that results from sharing of electrons, we call it a covalent bond. Then you find that now the bond between one water molecule and another water molecule is a hydrogen bond. So I find that which ones are stronger? So I find that the covalent bond are more stronger than the hydrogen bond. Let's proceed. Now we said that water is the universal solvent. Now that is one of the property. Then if you're going to just to remind you, what is a solvent? A solvent is just a substance a solvent is a substance that dissolves a solute. A solute is a substance that dissolves in the solvent, and the mixture of a solvent and the solute is called a solution. Now we're saying water is a universal solvent. It means it's able to dissolve a lot of solutes. It is able to dissolve a lot of substances. Now these substances are different. You can have what we call a polar substance, you can have what we call an ionic substance, and a substance that is non-polar. Now let's talk about these one by one. Now what is a polar substance? So a polar substance is one that has a negative end and a positive end. An example that we can give here is let's say glucose. You know, glucose is C6 H12, you know, O6. Now this is glucose. Now like we know that oxygen is more electronegative, so it tends to pull electrons towards itself, hence you know, establishing the positive and the negative part of the molecule. Now we've got what we also call an ionic substance. So an ionic substance, it also has a positive and negative end, but now in this case an ionic substance results from an ionic bond, and an ionic bond results from the transfer of electrons between atoms. A good example that we can give in this case, we can say sodium chloride, or your common salt. So now sodium chloride, it has two ions, the sodium and the chlorine atom. Now you know that the sodium atom, it has a positive charge when you dissolve it in a solution, and your chlorine has a negative charge. Now what this means is that metals like sodium, they tend to transfer their electrons. And I'll still ask the same question: which one is easier for sodium? Sodium is number 11 and it has 1 electron in its outermost shell. The valence electron for sodium is 1. So which one is easier? For it to lose 1 so that it attains stability, or for it to gain 7 more so that it gains stability? So it is easier for it to just transfer that 1 electron than to gain 7 more for it to attain stability. So that you find that most metals, they just tend to transfer electrons. Then for chlorine has 7 valence electrons. It has 7 electrons in its outermost shell. So which one is also easier for chlorine? To lose those 7 electrons so that it gains stability, or to just gain 1 so that it gains stability? So that's why the combination between sodium and chlorine atoms is very feasible, and that's what I'm talking about. So this is your sodium chloride. Now I must make mention that polar and ionic substances, these ones are called hydrophilic substances. Hydrophilic substances. Hydro in this case is just water. Philic, coming from phil, just means love. So these ones are water loving. Then we've got other substances which are non-polar. Things like oil, things like fats, glycerides. Those ones, they are non-polar. They don't dissolve in water, and they don't have charges. Now let's proceed. Now with me, I've got a diagram about chlorine and sodium. Now we must make mention that this is your chlorine atom, and it is negatively charged. You've dissolved it in water. It's in a solution, and we're saying water is a universal solvent. Now you've gotten your sodium chloride, and you've dissolved it in water. Now the ions will be just in the water. Now how is the arrangement in the water molecule when you dissolve these substances? So like for chlorine will have a negative charge, like we said, but now you find that around the chlorine you have water molecules. This is the first water molecule, this is the second one, this is the third one, and this is the fourth one. So now, because chlorine is negative, the hydrogen atoms on the water molecule, because for them they have a positive partial charge, so they tend to be like let me say the layer of the hydrogen molecules with the positive partial ends, they will point towards the chloride ion, and this is what the arrangement that you are seeing. This is the hydrogen atom is the partial positive, and this other one partial positive. They are facing in the direction for the chloride ion because of its negative. On the other hand, the oxygen atom, for it, is very far away, because the negative and the negative, they tend to repel each other. So this is the arrangement for chlorine. Then on the other hand, we've got the sodium ion. The sodium ion has a positive charge, and now you find that because of the positive charge, only the oxygen atom, which are partially negative, will be like very close to the sodium ion because of its positive charge. So this will be the arrangement. It's like the opposite of just the other thing. Now, non-polar substances such as O's have no charge on their molecules. They do not dissolve in water, and therefore they are called hydrophobic. I thought of mentioning that. Hydrophobic, phobic just means fear, and it's like they are water hating. They don't want water. Okay, now let's proceed. We're saying also, water is a liquid at room temperature. Okay, so water is a liquid at room temperature because of the hydrogen bonds that we just talked about. Then one water molecule can just form, hydrogen bonds with up to 4 other water molecules. Now this is very, very vital. Let me say I have a water molecule here. Now we're saying it can form a maximum of 4 bonds with up to other water molecules. So okay, let's start. Let me say you've got another water molecule here that is joined. Okay, this is hydrogen. Okay, it's connected to oxygen and another hydrogen. You can also make a bond here between hydrogen and another oxygen here. Oxygen, like that. Even this side you can also make another one where you have oxygen, hydrogen and hydrogen. On the other side also you can make another one where you have hydrogen, oxygen. Okay, like that. Now you're able to see from this representation that this water molecule, which is on the middle, it can form a maximum of bonds with other 4 water molecules. This is the first one, this is the second one, the third one, and the fourth one. Now let's proceed. We're saying water has a high melting and boiling point. So and the molecular mass of water is just about 18. Hydrogen, that's just 2 hydrogens, that's about 1.008 plus another 1.008, that's like 2.008 plus oxygen. It's number 8. So in terms of mass, it's 16 plus 2, that's like 18. So water is very light, but at the same time it has a melting point of the melting point of water. Melting point of water, you find that it's 0 degrees Celsius. What this means is that water melts at 0 degrees Celsius. It becomes a liquid at 0 degrees Celsius. Then also water has a boiling point, a boiling point of 100 degrees Celsius. 100 degrees Celsius. So this just means that water boils at 100 degrees Celsius. Now most of the substances, these values are so high. For boiling points, most of the substances are below 100 degrees Celsius. Then for melting points, most of the substances are below 0 degrees Celsius. They are in their negatives. So water has a high melting and boiling point because of some of these properties. Now the reason that water has a high melting point and boiling point is that there are strong forces of attraction between what we call hydrogen bonds between the molecules. So now let's proceed. We're saying water and temperature. An important thermal property of water is its ability to resist temperature changes. In this one we say water has a high specific heat capacity. This what it means is just that water needs to gain a lot of heat energy to raise its temperature, and conversely it also needs to lose a lot of heat energy to lower its temperature. So it takes a lot of energy to just raise the temperature of what we call 1 kg of water, to raise it to about 1 degrees Celsius. So when you get 1 kg of your water, you heat that 1 kg of your water. For it to just reach 1 degree Celsius, you need like it will take like a lot of heat just for it to reach 1 degree Celsius. And the opposite is also true. Like before the temperature of 1 kg of water falls by 1 degree Celsius, you need like a lot of energy to be lost. Yes, that's what it means. Now, I'd also want to make mention that there's what is called a calorie. Here we're saying 1 gram, 1 kg of water, but now a calorie has to do with 1 gram of water just for it to raise it 1 degrees Celsius. This one we're saying is a specific heat capacity. This one we're saying is a calorie. Okay, so let's proceed. Now, in biological terms, we say that this helps animals and plants to maintain a relatively like constant internal environment or temperature. So as the temperature like of water rises more, slowly, or drops so slowly, then the temperature of almost any other material gets to be constant. So we find that because of this, because of it being hard to raise the temperature of water, and it being the opposite being true, we find that most organisms are able to maintain a constant temperature. Then let's proceed. There's what we call high latent heat of vaporization. So a lot of energy is needed to evaporate water. Now, why is it so? Because when water evaporates from the surface of the skin or a leaf, or we're saying water has a high heat of vaporization. Now, how is this? It has a high heat of vaporization because when you heat water, the energy that the heat energy has to first go and break the hydrogen bonds first. Then that's when now it starts to raise the temperature of water. So I find that it takes a lot of time for water to just evaporate, because the hydrogen bonds have to be broken first. Then the liquid has to now, increase in temperature. Now, this is very important because when water evaporates from surfaces such as the skin or maybe even a leaf of a plant, those escaping molecules of water, they carry a great deal of heat, energy away from that organism or plant. So this evaporation has a cooling effect on that organism. Now let's proceed. The density and the freezing properties of water. Density is just is it your weight divided by volume? Yes. So I find that at 0 degrees Celsius, the freezing point of water, arranged in a regular structure in which water molecules are hydrogen bonded to other 4 water molecules. Now on this point, on this freezing and the density, I would want you to remind you that water is most dense at 4 degrees Celsius. You should not forget this one. It's most dense at 4 degrees Celsius. Now let's talk about cohesion and adhesion of water molecules. So cohesion is just the attraction of the attraction that happens between molecules that are similar or substances that are the same. And then adhesion is just the attraction between molecules of different substances. Remember, between water and the glass of a substance, because they're different, that one is called adhesion. Now the cohesion of liquid water is responsible for what we call surface tension. Water tends to form like a skin on top of it because of the adhesion, the attraction between one water molecule to another water molecule. Yes, so we find that these water molecules, they tend to have a much stronger attraction to like other water molecules, hence creating that like skin like structure. Now the adhesion, the ability of water to attract to other substances like glass or glass, you find that the adhesion of liquid water to other substances such as glass is responsible for what we call capillary action. And capillary action, or what is called capillarity, is just one of those forces which allows water to to go up a tube, or to go up a tube. So this is very important for things like plants, like high tall trees, or to transport water from the roots to their leaves. Now capillarity happens when the adhesion is more than cohesion. Adhesion is more than cohesion. Now I just thought of mentioning those. So these are some of the properties that water has. So you must know these properties one by one, and you must be able to explain what happens on each one of them, and state some of the importances of these properties of water. Now let's do some exam questions. Okay. The first question says, which of the following substances has a polar covalent bond between its atoms? Which of the following substances has a polar covalent bond between its atoms? Now, like we said, polar, it has to have a positive and a negative end. Covalent, we're just meaning there's some sharing of electrons that happens. Now, let's start with the first one. We'll be cancelling sodium chloride. No? Why? Because sodium chloride, it's by it's by an ionic bond. We said because sodium is a metal and it's easier for it to just transfer one electron, so because of that transferring, it's called an ionic bond. Then we've got the hydrogen molecule. Now, is it a polar covalent bond? Yes, hydrogen will share an electron with another hydrogen, but now you find that the electronegativity between the two is like it's cancelled out. In the end of at the end, you find that hydrogen won't have any charge because both of them are pulling electrons at the same force, so there's no charge on it. Then we come to glucose. Now, glucose, there's oxygen. When we said oxygen is more electronegative than other substances, so it will tend now to pull electrons towards itself. Now, because it's pulling electrons, it will leave others deficient, so it would be negative, the other ones will be positive, and our answer here is 3. Now, we talked about this question when we're doing atomic structure. Then the second question, which of the following substances contains an ionic bond? We said an ionic bond just involves the transfer of electrons, and one of the big good examples we said is sodium chloride. Let's go to number 3. Which of the following is true about the types of bonds in liquid water? We say water contains ionic and nonpolar hydrogen bonds. No, water contains hydrogen bonds only. Water contains both polar covalent and hydrogen bonds. Yes, like we saw our structure for water. You've got your H there, you've got another H there. Now, the bond between this hydrogen and the oxygen is covalent because they are sharing electrons. But for it to form another bond between oxygen and another water molecule, find that you have hydrogen here, and this hydrogen is connected to another oxygen like that. So these are two water molecules. This bond between this hydrogen atom of one water molecule to the oxygen atom of another water molecule is called a hydrogen bond. So water will have both the polar covalent bonds and the hydrogen bonds. Now let's proceed. Choose the statement which is correct. The carbon dioxide molecule has two covalent single bond. Now carbon dioxide, is something like this, and another oxygen the other side. Now, yes, it has, this is a covalent bond. There is a sharing of electrons that is happening, but on the other side it has a single, covalent bond. So this one is wrong. Then we're saying in the formation of carbon dioxide, electrons are donated by carbon to oxygen. They are not donated, they are not transferred. Actually, they are shared. So even this one is wrong. We are saying the water molecule has two covalent single bonds. Yes, if we draw again the water molecule is just like that and like that, and this is a single bond and this is a single bond. Now there are two, so this one is correct. Then in the formation of water, hydrogens are donated by electrons are donated by hydrogen to oxygen. Now this is not true. Electrons are not donated, they are not transferred, they are shared between the two. So this one is also not correct. So our answer here is just 3. Now let's go to question number 19. Choose the property which makes water an effective solvent. And we said the solvent is a substance that dissolves other substances. It dissolves what we call solutes. Now, want to choose the property which makes water an effective solvent. Is it the density property? Nope. Is it the high latent heat of vaporization? No. Is it the dipolar nature? Okay, this sounds true. Is it the high specific capacity? No. The surface tension? No. Now the dipolar nature, because it has a partial negative charge and the partial positive charge, it can easily react with, like we said, those substances. It can easily react with polar substances. It can easily react with ionic substances, because those ones are hydrophilic. Yes, so because of this dipolar nature, it's able to, act as an effective solvent. Then ice is able to float on liquid water because of dash. Ice is able to float on liquid water because of dash. Water has a high specific heat capacity. No, this has nothing to do with ice. Because of the high surface tension of liquid water, this has nothing to do with ice. Ice is insoluble in liquid water. Actually, the ice can melt. This is also wrong. Water freezes at 0 degrees, at 4 degrees Celsius. Okay, this is not correct. The density of water below the ice surface increases. The density of water below the ice surface increases. This is also not true, because for ice to just float on water, it's just that because we're talking about density here, so find that it's just that water is more dense than ice. So for me, I can just say there's no answer on this one. Now let's proceed. The cooling effect of water on plants depends on dash. Is it the covalent bonds? No. Is it the ionic bonds? No. Is it the heat of vaporization? The cooling effect, yeah, like we said, the cooling effect. First, when you're heating the water, because of its high heat capacity and its hydrogen bonds that it has, the energy has to first go and break the hydrogen bonds. Then when those hydrogen bonds are broken, now the energy rises. When it rises, it will reach at a point where it will start evaporating or boiling. Then what happens now? When the water evaporates, you find that it carries with it the heat energy, and by that action, it tends to cool other organisms, like we said, the skin and some plants. So this is correct. We're saying, is it capillarity? No, capillarity has nothing to do with the cooling effect of water. Then we're saying the best explanation of why certain insects can walk on water is dash. The effect of surface tension between water and the legs of the insects. Okay, let's jump this one for now. Because water gets frozen whenever such insects walk over it. No, this is not correct. The strong effect of cohesion at the water surface. Nope. Because all such insects have a lower density than that of water. Yes, they have a low density, but is that the reason why they are able to walk on water? Now, the strong effect of adhesion at the water surface. At the water surface. No, adhesion is between the water and the glass. It has nothing to do with the water itself. So let's look at the first one. The effect of surface tension between water and the legs of the insect. Here we are combining the legs of the insect and the water. So this one is valid, why the insects are able to walk on water. And like we earlier said, because of the strong cohesion forces. Cohesion forces are they bring molecules which are alike together. So I find that because the water molecules are able to form that bond between themselves, they will form like a sheath on top and like a skin on top, and that leads to like a surface, and that is called like a surface tension. And some of the insects can easily like settle on top and they will not like sink. Yes. Then in a water molecule, the non-bonding electrons in oxygen are dash or is dash. In a water molecule, the non-bonding electron in oxygen are dash. Like we earlier said, because oxygen has 6 valence electrons in its atom shell. Let me say this is first, this is second, third, fourth, fifth, 6. Now what happens when hydrogen comes? When hydrogen comes, it will share some of these electrons with oxygen. To share one of these electron. So to share one of these electron here, and the one for oxygen, it also share maybe also this other one, the one that it has and the one for oxygen. Now these other 4, they will remain unpaired, and these are the ones that cause the oxygen atom or the water molecule to have a bent structure, because they tend to repel the other electrons. So because of that, we are saying the non-bonding pair of electrons in the oxygen atom, they are 4. Okay, which of the following statement describes a covalent bond between carbon and oxygen? Which of the following statements describe a covalent bond between carbon and oxygen? Okay, so the electrons are shared equally between carbon and oxygen atom. No, that's not true. Oxygen is more electronegative. Electrons in the bond are closer to the carbon nucleus. That's not true. They are closer to the oxygen nucleus. Each atom in the molecule keeps its electrons. No, oxygen wants the electrons. Electrons in the bonds are closer to the oxygen molecule. Oh, this sounds true. The electrons in the molecule are very evenly distributed. They are not evenly distributed. So our answer in this case is 4. Electrons in the bonds are closer to the oxygen nucleus. Then number 9 says identify the correct description of the hydrogen bond. Now A is saying a bond between oxygen and hydrogen atoms of the same water molecule. Now that is not true, not of the same water molecule. A bond between oxygen of water molecule and nitrogen of other molecules like ammonia. Okay, let's keep this one for a minute. Then a bond between oxygen and hydrogen of different water molecules. A bond between oxygen and hydrogen of different water molecules. Okay, this one also sounds correct. Then a bond between two hydrogen atoms of different water molecules. Okay. So we left question number 2. We also left option 2. Now we're saying a bond between oxygen of water and nitrogen of other molecules like ammonia. Okay, now this is also true because yes, oxygen is more electronegative than hydrogen. There are other atoms which are more electronegative than hydrogen. You can have nitrogen. Nitrogen is more electronegative. You can have fluorine, and nitrogen is found in ammonia, so it can easily also form hydrogen bonds because it's more electronegative. It will pull electrons towards itself, hence it will also establish a partial positive and a partial negative charge distribution like that. So option 2 and option 3 above are correct, so our answer is 5. Let's proceed. Then choose a statement which distinguishes liquid water from ice. Choose a statement which distinguishes liquid water from ice. Okay, so we're saying in liquid water each molecule is surrounded by 4 other molecules. Now we're choosing the statement which distinguishes liquid water from ice. They've said liquid water. There's gaseous water. There's there's a solid part of water. Now we're talking about liquid water from the one that is frozen. So we're saying in liquid water each molecule is surrounded by 4 other molecules. In liquid water, molecules are more densely packed. In liquid water, the molecules are arranged in a regular pattern. In ice, the hydrogen bonds between molecules constantly make and break. In liquid water, molecules are less densely packed. Okay, like we earlier said, the hydrogens, they tend to break and form at the same time. So that one is a very, very vital part. So our answer here is 4. Then capillarity of water in a vessel depends on dash. And like we earlier said, capillarity is just, the ability of water to travel along or up a tube. Yes, so now that capillarity, does it depend on adhesion, water's density properties, cohesion, 1 and 2 above, 1 and 3 above? So it's dependent on what? The ability first of water to hold itself, then the ability now of water to hold to other molecules. So that is adhesion and cohesion. So which one are the answers? We've got 1 and we've got 3. So 1 and 3 above. So our answer here is 5. Now they're asking the meniscus of water in a narrow tube is dash. The meniscus of water in a narrow tube is dash. The meniscus is just that curved surface that water tends to make. Is usually very visible when you're using glass. So now we're saying curves upward due to high. Let me try to draw. Does it curve upward? We're saying so it looks something like this. Okay, so it curves not really like upwards, but it curves downwards. So this one is wrong. We're saying it's flat because of the force of gravity. It's not flat. it caves. So this is wrong. It caves downwards due to cohesive forces between water molecules. Not really, because we're talking about it making a shape, a caved shape. So it must be between the glass itself and the water molecules. It has nothing to do just with the water molecules themselves. So this one is also wrong. It's flat because of the high surface tension. Not really. Caves downwards due to the adhesive forces between water molecules and the tube within. Yes. So this will be our answer. Okay, let's proceed. Then, which of the following statement is true about water? Hydrogen bonds are as a result of electron attraction between water molecules. Water is capable of sticking to the sides of glass using cohesive forces. Okay, that's not correct. Water molecules form spheres on a polar surface. Water is a polar molecule because the electrons on oxygen and hydrogen are equally shared. No, adhesive forces help water molecule to stick to each other. This one is also wrong. So what is our answer? Saying hydrogen bonds are a result of electrical attraction between water molecules. Yes, like we said, it's between one water molecule and the other water molecule. So this is the correct answer. Which of the following statement is not true? Not true about water. They're saying when water boils, covalent bonds are broken. I think this is the one that is not true. Like we earlier said, it's the hydrogen bonds that they're the ones that break when you hit water. Not really. It's very hard actually to break these covalent bonds. So then the other options are saying water molecules are hydrophilic. Yeah, that's true, but we're looking for what is not true. Water molecule is not linear. It's not linear. We said it has a bend shape. That's true. Water is an excellent solvent for polar substances. Yes, it dissolves polar substances. Water has a very high latent heat of vaporization. Okay, we also talked about that. That is also correct. Choose a statement that is correct in relation to isomerism in monosaccharides. Oh, we haven't started talking about biomolecules, but okay, we can still answer this one. Isomerism, we just talk about substances which have the same structure but in the same formula but different arrangements on how certain atoms are arranged. So like in this case we're talking about the alpha glucose and the beta galactose are stereoisomers of each other. Stereoisomers are just talking about what we call mirror images of each other. Yeah, mirror images of each other. So they have the same structure, but the way the atoms are arranged is different. So it's like a mirror. You can't really they are non-superimposable. You can't put them together, but they just stand alone like that. So we find that there's alpha one and the beta one. But now in this case we've got glucose and galactose. Same structure, but how the OH or the hydroxide arrange is really different. So in this case our answer is 3. But yeah, we're going to talk about this as well as we'll be talking about biomolecules. Then number 3 says polar molecules can readily dissolve in water because of dash. Polar molecules can readily dissolve in water because of dash. Polar molecules can form hydrogen bonds with water. Polar molecules can replace water interaction with more energy provided. Water can interact with charged solute molecules. Okay, that sounds true. All molecules form solutions with water. Not all. Of both option 1 and 3. I don't know. Okay, don't put I don't. Don't put a lot of I don't knows in the exam. You must know something. Okay, but again, don't guess because there's negative marking. Okay, so we say number 1 saying polar molecules can form hydrogen bonds with water. Okay, that's really true. Yeah, because of the charges, and water has a charge, so they can easily react. So the first one is correct. Polar molecules can replace water. No, they don't replace. Water can interact with charged solute molecules. Okay, that's also true as long as they are charged. But now solute molecules, the ones that can easily dissolve in water. So option 1 and 3 are correct. So answer here is 5. The most important reason for the unique shape of water is that we talked about this. Okay, so the covalent bonding pattern in water molecules Is it the bond angle between the two hydrogen atoms in water, the presence of lone pairs of electrons in water, that water can be ionized at room temperature? All options above are correct. Okay, so let's start. The covalent bonding pattern in water molecules, is it the one that is responsible for the shape of what that band structure? Not really. The bond angle between the two hydrogen atoms in water. Now the bond angle is between the hydrogen and the water, but now what really results into that? Because it's the one that caused the, so this one is not it's not complete. Then the presence of lone pairs of electrons in water. Yeah, like we said, those four unshared pairs of oxygen, electrons. It's the one that tend to like to cause now like repulsion, and that hence we have that structure. So answer here is 3, the presence of those lone pairs of electrons. Now let's do the last part of these questions. Hydrogen bonds can be expected to form only between hydrogen and dash. Carbon, hydrogen, oxygen, nitrogen, option 3 and 4. Like we said, the hydrogen bonds form between the hydrogen atom itself and a more electronegative atom. Okay, is carbon more electronegative than hydrogen? Okay, it is, but it's very slight. It's very minimal that it can even cause a charge. So this is not correct. Hydrogen, can it also hydrogen to another hydrogen? Because they are pulling electrons at the same force, so it means they won't also form hydrogen bonds. There'll be no charges there. Then oxygen is more electronegative. It will form a negative charge, a partial negative. Even nitrogen, like we said, is also more electronegative than hydrogen. So these two are correct. So our answer is option 5. So option 5 is our answer. Then adhesive forces lead to dash, which is the process through which water is absorbed into roots of plants. Now we're talking about adhesive forces and process by which water is absorbed into the roots of plants. Yes, and like we said, we talked about plants earlier. We were talking about capillarity because of the adhesive forces between the water molecule and the vessels. Water tends to rise above, like in a tube. So because of that, that is also possible in trees and plants. So the water is able to move from the roots of the plant until it reaches to the stems and it goes to the leaves like that. So that one is because of capillarity action, or capillarity if you want to call it. So our answer here is 5. Okay, thank you for for joining this session. Meet you in the next session where we're going to talk about biomolecules. Yeah, thank you. See you in the next session. 26.